suppose you had a Bible, very valuable Bible, and somebody asks you for a copy of the Bible. So what you do is you say, well, I can't give you the Bible, but what I can do is I'll photocopy the pages. Now, it's a long process, of course, so what you do is you start photocopying the pages. You take each page and you fold it up, you put it in an envelope, and you address it to the person, and you put it in the out tray. You keep doing that as you photocopy the pages. Postboy comes by, collects what's in the out tray, takes it down to the post room, it disappears into the postal system. Meanwhile, you're still copying the Bible page by page, and you're sending it off one page at a time in the envelopes. The guy at the other end, receiving the envelopes, not necessarily in the same order that you sent them, opens the envelope, takes out the page, looks at the page number, reassembles the Bible in the correct order, and now he's got a photocopied version of the Bible. And of course the postal system in the middle didn't have to carry a whacking great precious Bible. What it carried was little pieces of the Bible, chunk by chunk, packet by packet. That's what packet switching is. You take your original data stream or your data set and you chop it up into small pieces, you transmit that through the network. Each piece is separately addressed, finds its own way through the network, recipient gets it, puts it back together into the original block or stream or whatever. But that's basically what it is. That's what it is. Why do you do that? It's to do with queuing. If you have packets arriving and they're all little pieces, then you can very quickly sort them and send them on their way. But if you've got a whacking great message that's stuck being transmitted down the line, then you've got to wait for that to finish before anything else can happen.
And it was interesting that Donald Davis, who started all this, observed that in the same way that large mainframe computers sliced up their programs for the benefit of the operators, why couldn't we slice up the communication mechanism between the terminal and the computer in much the same way? And basically for the same sort of reasons. Because what you needed to do when operating these programs every so often was to put in a very short message, which was a command or something. And there was a real danger that if you use the telephone line in the traditional way, that this command would be delayed because there was a long message on the line. So the origins of packet switching were really rather similar to the way that the batch processing mechanism developed, in that the communication network was sliced up in much the same way in packets.
When Donald Davis first mooted the idea, his first paper was internally published 1965, when it was actually published, and he, one of his two lieutenants, a man called Derek Barber, who was my boss, and they discussed setting up a small research group, which they did. And so Derek came to me and said, I want you to lead this small group, and you can have two people to work for you. He's one of them, so Keith Bartlett. The other is Peter Wilkinson, Dr. Peter Wilkinson, who was our software expert. And so between the three of us, we started to just put flesh on the bones to try and work out how you would design such a system. And then when we got to a certain point where we were able to publish the work, Donald was able to appropriate funds to allow us to expand the team, and then we got some other guys in, like this guy here, to work on actually building the network and deploying it as a service. When we first started, we were just going to build something to make it work, to show that it could work. So it was very much just going to be a straw man system. But fairly quickly, I think Donald realised that in order for it to have any impact, it needed to be a proper working system. And we actually built the network, and it went live in service, I think, at the beginning of 1970.
The finger was pointed at me to write the software, which wasn't a problem, because, I mean, that was my role, and I sort of accepted the challenge. But I went away from that meeting feeling a little bit pretty nervous, because I mean, nobody, as far as I know, had ever written anything like that before. It's all completely new. And where do you start? So the decision was taken fairly early on that we'd have to write software from the full bare machine. No, just using the assembler, no support from Honeywell pre-existing software whatsoever.
I think when he first ran it, there were 2 bugs.
I don't remember those. I was, having been responsible for the hardware, I was furious because his software worked first time.
Well, very nearly.
And one of the key inputs for me was a paper which I got via Mike Woodger by Edgar Dijkstra, who was one of the gods of computing science, called Cooperating Sequential Processes. And that gave me one of the key ideas that what I needed to do was to structure the software in the computer to sort of mirror the outside world where lots of independent things were going on by means of a collection of processes within the computer software.
The beauty of the NPL site was that it was a multidisciplinary site. So the network did 2 things. It served the needs of the laboratory in order to enable the scientists and engineers to get access to the computers, but it also tested out the ideas of packet switching, and it tested out the ideas of packet switching under a realistic situation.
There was another service that had been pioneered by another team, and they'd come up with something called Scrapple, which was an information retrieval system. Once they connected that to our new network, all the scientists could type their papers directly in via a teletype or a visual display unit and get it recalled instantly. And that was absolutely true. So this was an information system, a server, although we didn't have the name at the time, we call them a server.
Yeah.
It was a server where you could put in information. You could edit the text.
Yeah.
So it was a bit like a word processor in a sense. But then people started sending messages to each other because you could exchange information. Somebody else's files that you could actually an email system. Email at the time. A data repository. But sorry, the interesting thing I was going to say was because people started typing their own papers, the need for typists to cut carbons and do all of that sort of stuff just disappeared.
I got told off for typing in my own reports. The Human Resources Department, it wasn't called that then, but they were very concerned that the typists and the secretaries were being underused, and I had no business typing my own reports into a computer.
So the network was multi-user and multidiscipline, and that was a fortunate situation for us to be able to take the ideas and build something and actually use it. The other thing we ought to say about this is that when we first put the network together, we decided that speed, because this is a network site that was owned entirely by the NPL, we weren't constrained to use telephone wires. So we put in high capacity links everywhere, and even every single user who had a terminal had a 1 megabit per second link. And of course at that time people were going, that's crazy. You know, you've got a typewriter and you've got a 1.5 megabit link. Well, if you think now, of course, that most people have 2 or maybe 8 megabits coming into their home, it isn't a silly idea, but at the time it was regarded as being rather strange. Spread out from building 93 to cover eventually more or less every building in the laboratory.
Yes.
By the beginning of the 60s, the telephone networks around the world, particularly in the USA, I guess, had